right, so as I mentioned last week, this week we're going to focus on absolute value, but absolute value functions. Okay, before it was equations, so I showed you how to do the algebra, but now you're going to have to graph the function. I'm going to show you a couple of ways of doing this, and then you can pick and choose whichever one you like. Um, but I think if you treat this like a quadratic function, the way we graphed quadratic function, that I think that would be slightly easier. Okay, so anyway, so let's start off with the definition of an absolute value, right? So the absolute value of x, right? If it's positive, right? If the x value inside your absolute value is positive, it stays the same. If it's negative, then you have to multiply the x value by -1 to make it positive, okay? So just to refresh your memory, remember absolute value of -5, right, is equals to 5, okay? But how do you get the 5? Okay, you can just magically turn a negative number into positive number. You have to multiply this negative number by -1, okay, by attaching this negative sign, okay? So you have to attach that extra minus sign to the -5, right? So this extra minus sign is just multiplying -5 by -1, which gives you 5, okay? So again, in the case of numbers, you can go directly there, no issues. But when you're working with variables, this minus sign becomes crucial, okay? And if your number happens to be positive, right, if it's a 3 or something, then because it's already positive, your absolute value does nothing to it. And if it's 0, right, then it still falls under this umbrella, right? So this tells you that if the x value is positive or equals to 0, then you leave it the way it is. Okay, so 0 remains 0. So these are essentially your three cases: negative, positive, and 0. Now let's define something. So as you can see, this fancy definition of an absolute value, um, we're gonna give this a definition. Okay, so I'm going to introduce this new definition called piecewise function. So, what is a piecewise function? It's a function composed of two or more separate functions. Okay, in the case of the absolute value, we have two separate functions, each with its own specific domain that combine to define the overall function. Okay, and a perfect example of a piecewise function is the absolute value function. Why? Because y is equals to absolute value of x can be rewritten as y is equals to x, right? If x is greater than or equal to 0, so if x is positive or equals to 0, it stays the same, or minus x if x is negative. Okay, so this is a piecewise function. Why? Because it is composed of, as you can see, two. In this case, it could be more, but in the case of the absolute value, it's two, right? It's composed of two separate functions. Okay, this is your first function, this one over here, y is equals to x. Okay, so this is y is equals to x. This is your first function, and the second function is this one, y is equals to minus x, each with its own specific domain. Okay, so the domain of y is equals to x is this, okay, and the domain of y is equals to minus x is this. Okay, so they have their own domain. Okay, so piecewise function. So how do you graph a piecewise function, right? You can graph this by graphing each piece separately, which is what I'm going to show you. So that's like one way of graphing it, and then I'll show you another way, which kind of like where you don't have to do that. Okay, so let's why don't we graph, let's just use different colors. Okay, so let's just, I'm gonna use purple for this and then green for this. Okay, so if I asked you to graph this function, right, the this one over here, right, and this is just y is equals to x, right? Because here you have your y, you have your equal sign, and then you have your x. Okay, so that's why this is y is equals to x, but just be careful, it has a domain. Okay, so let's not worry about the domain for now. Let's just graph this simple function, y is equals to x. Okay, So again, how do you graph linear function? You just kind of have to, you know, just use the y-intercept, right? So compare this function to, let's say, y is equals to mx plus b, right? If you compare the purple function here to the red function there, you know that your slope in this case is equals to 1, and your b value or your y-intercept is 0, okay? Because m is 1, that's why your coefficient here is 1, right? And plus 0 if you want, but you never write the plus 0, okay? So graphing this is should be fairly straightforward, right? It's just a question of drawing a Cartesian plane, okay? And let's do that very quickly. So this is your x, this is your y. So because my y-intercept is 0, right, using this, my slope is positive, so that means my function is rising. Again, I'm just sketching it, so you can just say something like that, okay? Something like this. But remember, this is your function in purple, okay? This one is y is equals to x. But you see, now you have a problem, okay? You have to be careful. The domain of this function is x has to be greater than or equals to 0, right? So x is 0 over here. It's greater than or equals to 0 from here, moving on this direction. So that what that means is that this branch over here, I need to delete this, okay? And there's a couple of ways to convince yourself why this one has to disappear. First of all, it's not within your domain because this branch over here, the x values are less than 0. Secondly, right, if you go back to the definition of absolute value turns negative numbers into positive numbers, right? So in this case, if you pay attention to this branch over here, this one, you can see the y values here are, oops, how do you get rid of this? I always have a hard time. Okay, so the y values down here are negative, okay? Which is why you're essentially getting rid of this piece, because remember, you cannot have negative values in an absolute value function, okay? But if you follow your domain, it tells you that x has to be greater than 0, so that means this branch needs to disappear, okay? Now, what do you need to do next? You have to graph the second piece. I'm going to do that in green. So this is the function, if you want y is equals to minus x, and using the same logic, if you compare this to mx plus b, you can convince yourself that the slope here is -1 and that the b value is 0, okay? Maybe I should have, yeah, okay, let's just leave it there, no big deal. So how would you graph this function? Again, because the y-intercept is 0, you're going to start at the y-intercept. Slope is negative, so that means your function is decreasing. Okay, so this is decreasing. And it's a linear function, so it has to continue this way, okay? So let me just do this, make this straight. Now, this function also has a domain. The domain is x has to be less than 0. So that means this function only exists from this dot, moving leftwards, right? So that means this branch, you need to get rid of this branch, okay? So this is your absolute value function. This is what the absolute value looks like. So again, I'm going to just erase all this stuff just to make some space, okay? So you have two branches, okay? This one, let me clean this up a little bit. So this one here in purple, right? This is your first function, y is equals to x, but it's only defined for x is greater than or equals to 0, okay? So it's this branch over here. And the second branch is this one in green, and your function is minus x, and it's defined for when x is less than 0, okay? So we're talking about this branch over here. So you can see, if you graph the two piecewise functions separately, right, then you have your absolute value function. Okay, so that's one way of doing it. And obviously this might be a little confusing to some of you. I'm hoping it wasn't too confusing. All I did is I graphed the function in purple and I respected its domain. Right? It's just a linear function, and then the function in green, right? This one. but I respected its domain. Okay, so I had to get rid of this piece over here, right? This piece had to disappear for the function in green. And for the function in purple, this piece had to disappear. Hold on, let me just clean this up a little bit. So for the function in purple, this piece had to disappear, okay, because it wasn't within your domain. So it's just a question of graphing two linear functions. Okay, so if you understand linear functions, you understand how slope works, how y-intercept works, and it shouldn't be too difficult. But I'm actually gonna hopefully make it a little easier by showing you another method, okay?